Hello everyone, my name is Rudieri.GameDev, and from now on I will be presenting the work entitled Manual Printed Circuit Boards Assembly using augmented reality towards total quality. For a brief introduction for the work, we are bringing on the concept of Assembly 4.0 that unites another concepts already existent in the literature, like the Industry 4.0 when we talk about the IT integration in the production process. When in this work we are bringing on production system based on augmented reality technologies for improve the manual production assembly lines, improve the quality using the concepts in premise of the total quality management to develop a system for that uses augmented reality technology in the context of manual production assembly of printed circuit boards. To make this made this study, we firstly look for another related works in the literature and find it's 5 different works that bring different ways to solve this problem. We find works about the use of intelligent augmented reality for motherboard assembly using handheld devices like smartphones or tablets. The use of augmented reality-based training for PCB assembly using hand-mounted displays like HoloLens or Google Glass. The augmented reality and sensing device for manual assembly workstation using the multimodal devices, and for the augmented reality using the head-mounted displays. Long-term analysis of on-situ instruction at the assembly workplace using fixed webcams in the workbench and projections to show the augmented reality information, and works about the impact of monitor-based augmented reality that uses a combination of fixed webcam and traditional monitors. So we have 4 different hardware setups that we identified in these related works. From all the benefits that the works bring, the 3 main identified by us was the last assembly errors in the production assembly line, the lower mental stress rates from the workers that produce the printed circuit boards, and the fastest assembly times of the assembly lines when using the augmented reality system. In that way, we started working in our case of study, working with a real fabric in a real industry that produces printed circuit boards to investigate the limitation, peculiarities, and information included in the assembly line in the printed circuit boards production environment to bring on things that could be important from the system, like on the assembly line, the worker receives the printed circuit board in a certain assembly stage, and after that, they must insert appropriate parts and send to the printed circuit boards to the next step when another worker in another bench will make the assembly of the parts that they are designed to be. The assembly stage are divided into different workbenches with only 1 worker per bench, and all the parts required for the assembly stage are arranged in front of the bench and present very different sizes, different shapes, different colors, and must be inserted in the certain order to prevent errors in the circuit board. Also, for ergonomic reasons, it's desirable that operators be free of wearables, so both hands need to be free to manipulate and put the parts in the printed circuit boards. And also for this, some monitors are presented in the workbench that display electronic assembly manuals that already are in the assembly lines. And from this, because of this, for the 4 hardware configurations identified by the related works, we choose it to use the fixed webcam and traditional monitor approach because of the lower cost of implementing the system in an assembly line that already has monitors on the assembly line, and also because of the ergonomics of not putting any wearables on the worker. So from the development tools chosen by the project, we tested for different software development kits, the IR toolkit, the wiki tool, and the DZIR and the Buforia. And then ended up choosing the Buforia because of the most precise presentation of augmented reality objects in the printed circuit board itself, using the printed circuit board image as a fiducial marker. So the Buforia was the one who presented the best results in the stability of the augmented reality objects. And from that on, we designed a system architecture that propose a system that should provide a lot of information for the worker in the assembly line, like what parts are supposed to be assembled in this step of the PCB, when those parts should be assembled, when I should use a tool to assemble that, how many of those parts will be assembled on the printed circuit board, where they are to be assembled, and from where they are on the workbench, what way, some orientation that should be used in that part specifically, and how much, what are the conditions to leave parts. There are any parameters to be concerned about. So we designed the system with 4 different modules: an entry model with a fixed webcam, a process model with augmented reality user interface, pattern recognition, product management, database, and the presentation of the augmented reality information by the traditional monitor. And with this, the conclusions of the work shows that in the related works, there are no methodologies that are standard for this type of system. There are no patterns to be defined yet. And also the system presents clear benefits on the studies that we already have published on the literature. And so for future works, we want to go deeper in the daily life of the assembly worker to implement and test the system. And that's it. Thank you very much.